Your MCP server can do more than just answer questions. It can become a research assistant with proper search and fetch capabilities. We'll implement the two required tools that unlock deep research mode in ChatGPT: a search function to find matching records by query, and a fetch function to retrieve full record details. You'll see exactly how to structure these tools so ChatGPT can systematically analyze and cite your data. At MCP tool, def search query, SDR dict. Search for records matching the query. Must return IDs, list of string IDs. Hash your search logic. Matching IDs equals ID1, ID2, ID3. Return IDs, matching IDs. At MCP tool, def fetch ID SDR dict. Fetch a complete record by ID. Return the full record data for ChatGPT to analyze. Hash your fetch logic. Return id. Title, record title. Content, full record content. Metadata, author, Jane Doe, date, 2024. This demonstrates the tool interface pattern for structured information retrieval, specifically designed for AI-assisted research workflows. The pattern defines two distinct but complementary operations: a lightweight search to identify relevant records, and a detailed fetch to retrieve complete data. What makes this distinctive is its explicit separation between discovery and content acquisition, mirroring how humans first locate, then examine information. The approach follows a declarative contract model, where each tool enforces a strict input-output schema through type hints and docstrings. The search tool acts as a filter, returning only identifiers, while the fetch tool provides rich, structured data for analysis. This division enables efficient multi-stage processing, where the AI can first narrow scope, then deep dive into specific records without overfetching data up front. This pattern solves the cold start problem in AI research tools by providing a standardized way to expose knowledge bases. It's particularly valuable when integrating with large language models that need to ground responses in external data. The trade-off is initial setup complexity, but the payoff is seamless interoperability with AI systems that expect this exact search-fetch duality for deep research capabilities. Let's break it down line by line. At MCP tool, def search query, SDR dict. The at MCP tool decorator exposes this function as an AI callable tool. FastMCP uses the type hints and docstring to auto-generate the tool's schema, ensuring consistent input validation and documentation. This is the standard pattern for defining tools in the FastMCP framework. Search for records matching the query. This docstring defines the search tool's purpose, finding records that match the user's query. It establishes the contract that this function must return a dictionary with an IDs key containing matching record IDs, enabling the AI to request specific records next. Must return IDs, list of string IDs. This enforces a strict return schema for AI interoperability. The search tool must return a dictionary with an IDs key containing string identifiers, ensuring the AI receives predictable, structured results for downstream processing. This pattern guarantees type safety between Python and the AI model's expected input format. This opens a Python docstring, the standard way to document functions, classes, and modules. Docstrings become the tool's schema when using at MCP tool, defining the interface for AI models to understand and call the function. Hash your search logic. Matching IDs equals ID1, ID2, ID3. This placeholder implements the search logic stub. In production, this would query your database or search index and return matching record IDs. The array format ensures compatibility with FastMCP's expected response schema.
Return IDs, matching IDs.
This enforces the required return schema for search tools. The dictionary with an IDs key containing a list of strings is the standardized format FastMCP expects, ensuring consistent AI integration.
At MCP tool. Def fetch ID SDR dict.
The @MCP tool decorator marks this function as AI callable, exposing it to models through FastMCP. The type hint id, SDR, and return annotation dict define the tool's schema, while the docstring provides human-readable documentation that AI models can also interpret. This is the standard pattern for creating tools that bridge Python logic with AI workflows.
Fetch a complete record by ID.
This docstring defines the fetch operations contract. Retrieve a complete record by its unique ID. It enables the AI to request full record data after getting search results, implementing the two-phase retrieval pattern common in search systems.
Return the full record data for ChatGPT to analyze.
This specifies the return contract for AI tool integration. The function must return complete record data in a structured format, enabling ChatGPT to process and analyze the full context of each record. Without this, the AI would only receive partial or inconsistent data. This opens a Python docstring, the standard way to document functions, classes, and modules. Docstrings become the tool's schema when using @MCP tool, defining the interface for AI models to understand and call the function.
Hash your fetch logic. Return.
This defines the response structure for the fetch operation. The dictionary format ensures consistent data delivery to the AI model, with all required record fields explicitly included. This pattern guarantees the AI receives complete, predictable data for analysis.
id.
This includes the original ID in the response payload, maintaining data consistency between requests, critical for traceability when the AI needs to reference specific records from search results.
Title, record title.
This defines the record's human-readable title in the fetch data structure, required for AI models to properly reference and display records in responses, ensuring context preservation when processing multiple documents.
Content, full record content.
This defines the actual content payload that will be analyzed by the AI. The fetch tool must return complete record data, and this field contains the main text or data body that the AI will process, reason about, or extract information from. Without this, the AI would only see metadata and identifiers, making meaningful analysis impossible.
Metadata, author, Jane Doe, date, 2024.
This nested dictionary implements structured metadata storage, a common pattern for attaching machine-readable attributes to records. The key value pairs enable flexible extension without schema changes, while maintaining predictable access to core attributes like authorship and creation date. This closing brace terminates the fetch tool function definition, completing the implementation of both required tools for FastMCP integration. The paired structure of search and fetch enables the full workflow. AI discovers records via search, then retrieves details via fetch. FastMCP tool design pattern. The search and fetch duality in this example mirrors FastMCP's core principle of separating discovery from retrieval. where tools expose minimal interfaces while maintaining rich internal logic. Query parameters in resource URIs become part of the public contract, so type hints must match the expected client input exactly. This pattern enables AI models to reason about data relationships without understanding the underlying implementation.
The URI that names everything becomes the thing that needs no name.